Paper documents often serve as vital items of evidence for prosecution and defence lawyers in a court of law. As part of my research, I am exploring new scientific techniques for testing inks from pens. Ink analysis can provide important forensic evidence in an investigation where a particular document is alleged to have been tampered with in some way in order to change its original wording. For example, analysis of the ink on a cheque may reveal that it has been altered to increase the amount of money it is for. Alternatively, it can provide the police with an indication of the type of pen and ink used to write a ransom demand in a kidnapping case. It may even be possible to provide the police with the name of the possible brand of the ink that is being used. There are 5 basic types of pen available in the world today, each with their own specific type of ink. There is the fountain pen that contains a water-based fluid type ink delivered to the paper with a nib. This pen was first invented in 1884 and was the writing instrument of choice for around 60 years. Then, at the end of World War II in 1945, the ballpoint pen was invented. This pen uses a solvent-based paste-like ink delivered to the paper via a small rolling metal ball at the tip of the pen. Because of its ease of use and low cost, the ballpoint pen rapidly became more popular than the fountain pen, and over 60 years later is still the most popular pen in the world today. Nevertheless, the swinging 60s saw the introduction of 2 new types of pen: the porous tip, more commonly known as the felt tip pen in 1962, and the rollerball pen in 1968, both of which contain water-based fluid ink. That's 4 different types of pen, but what about the 5th? Well, I will come to that in just a moment, but for now it is important to know that all 4 of these pens have one thing in common. That is, they all use dyes to give the ink colour. These dyes are powders that dissolve in solvents, and are therefore called soluble dyes. Because of their solubility, these inks can be tested using a technique called chromatography, where a sample of ink can be separated into its different dye components. In the 1970s, forensic scientists developed ways to test fountain, ballpoint, felt tip and rollable pen inks, so they were able to tell those with different chemical ingredients apart from one another. These tests start by looking at the ink on a document through a microscope to study its colour and general appearance, which may give a clue as to the type of pen used. The next test would be to place the ink on the document under infrared and ultraviolet light, using a special piece of equipment called a video spectral comparator, or VSC for short. Under these special lights, the inks may fluoresce or glow. Inks with different chemical ingredients may glow in different ways or show different levels of brightness. In this way, it is possible to tell if different areas of writing on the same document may have been written with different inks, which could provide evidence that the document has been altered. Sometimes it may not be possible to tell inks apart using these 2 tests, even if they do contain different chemical ingredients. When this happens, a 3rd test, called thin layer chromatography, or TLC for short, can be used. Samples of the ink are removed from the document, dissolved into a chemical solvent, and transferred onto a flat TLC plate. By placing this plate upright in a glass tank containing a small amount of a specially chosen solvent mixture, the different dye components present in different ink samples can be separated out and compared to see if the components from different areas of ink on a document are the same or different. Obviously, if they are the same, then the inks may be from the same pen. If, however, they are not, then the inks must have come from a different pen, again providing evidence that a document has been written with more than one ink. This combination of tests has proved to be very successful for forensic cases for the last 30 to 40 years. However, in the past 10 years or so, a new type of pen with a unique type of ink has become popular: the gel ink pen. These pens use inks that are like a gel rather than a fluid or liquid, and usually contain fine particles of colour called pigments rather than dyes to give the ink its colour. The gel ink is delivered to the paper using a similar metal rolling ball mechanism to that used in the ballpoint and rollerball pen. When the ink pen is not in use, the ink inside the barrel is a solid gel, but as soon as the pen is used, the friction from the metal ball turns the solid gel into a liquid which then smoothly flows over the metal ball onto the page. This smooth flow of ink, together with a wide range of bright and vibrant colours and an environmentally friendly, non-toxic chemical composition, has made the gel ink pen the fastest growing type of pen in use today. This ever-increasing popularity means that forensic scientists will begin to see more and more documents in their laboratories written with gel ink. This creates a problem, since they use pigments which do not dissolve in solvents, making it difficult to test them by TLC. Moreover, because it is not always possible to tell different inks apart using microscopy and the VSC, the ability to tell different gel inks apart becomes harder. So a new way to test and compare different gel inks must be found, and that's where I come in. One method that I have been looking at in detail is Raman spectroscopy. This is a scientific technique that directs a laser light of a specific wavelength through a microscope onto ink on a document. As the laser light interacts with the different chemical bonds that make up the chemical structure of the ink, some radiation that has shifted to a longer wavelength of light is scattered from the surface of the ink and collected through the microscope. This radiation passes through the microscope and into a spectrometer, where it is detected and the information it contains converted into a visual display on a computer screen. This display, called a Raman spectrum, is made up of a series of peaks of different heights that represent a particular type of chemical bond in the ink. Different brands of ink may contain different chemicals, so their Raman spectra should also be different, thus providing a fingerprint or chemical signature that can be used to compare inks. As part of my work here at the university, I have analysed ink from over 400 different gel pens of different brands and models, and using different Raman spectrometers. I am testing the different instruments to see which one give the best results. The results have allowed me to place different brands of gel pen into groups based on a comparison of their spectra by eye. This information provides the forensic scientist with an idea of how common a particular ink is, as well as how useful the technique of Raman spectroscopy is for telling different brands of gel ink apart. I've also been investigating if we can tell different brands with similar spectral patterns apart using statistics. Using a computer software package, it is possible to group brands based on their spectral pattern into groups. Using a computer to do this means that the decision is made objectively, removing any human bias. A chart called a dendrogram can be produced showing how the different brands can be grouped and how similar they are to other groups. As my research continues, I will explore other techniques for the analysis of gel inks. When I have completed my work, I should be able to recommend a new series of tests that can be used to compare different brands of gel ink that can be used by forensic scientists around the world.